Hi everyone, in today's presentation we will be looking at chapter 6.1 in the OpenStax Intermediate Algebra textbook, which is the greatest common factor and factor by grouping. More specifically, we will be looking at learning objective number 2 in this chapter, factor the greatest common factor from a polynomial. Now, if we bring up the textbook from OpenStax, this is a open source free textbook that you can find. We're looking again at the Intermediate Algebra 2nd edition, chapter 6.1, greatest common factor and factor by grouping. And we are looking at factor the greatest common factor from a polynomial, the second objective. I did create a video on the first objective as well, which you can find in the YouTube playlist. Now, looking down this chapter, this is the section we are specifically looking at. So the reading that is below here, you can go through, look at some of the examples and try out some of those questions. And then at the bottom of the chapter reading, you can find the section 6.1 exercises, and this video matches up to this section right here, and questions 9 through 36. Okay, so feel free to take a shot at these questions after viewing the video. Let's first start by answering the question, what is the distributive property? So the distributive property says that multiplying a number, A, by a group inside parentheses, so we have our parentheses and B plus C, is the same as multiplying that number A and A by each term inside the parentheses. So that's A times B and A times C. Now, to put some numbers and more concrete items to this, let's go ahead and say if we had 4 parentheses 3 plus 5, this is the same as saying we have 4 times 3 plus 4 times 5, right? In other words, if you were to think about, okay, if I had the group inside the parentheses and I added these two numbers, 3 plus 5, I would have 4 times 8. And then 4 times 8 would be equal to 32. Or if I broke up those terms that I multiplied 4 into 3 and 4 into 5, I would have 4 times 3 is 12, plus 4 times 5 is 20. Adding those two items together, we would get to 32. Now, the distributive property can also be applied in reverse. So, if I think about it in terms of reversing the distributive property, I'm thinking of it in terms of factoring it. So, for example, in reverse, we would have A and B plus A and C, which is the same as A parentheses B plus C here. Essentially, why I would do this is if I wanted to factor out a greatest common factor, right? So again, if I had 4 times 3 plus 4 times 5, and really this is 4 times 3 is 12, and 4 times 5 is 20, essentially we could think about, okay, what is the greatest common factor that I can factor out of 12 and 20? Well, that would be the number 4, right? So if I factored out 4 from 12, 12 divided by 4 is 3. That's where I get this. And this is where I have the parentheses, 3. And then 20 divided by 4 is 5. So applying the distributive property in reverse basically means we are factoring out a number, and generally we can factor out the greatest common factor, the number 4, which we are going to apply to several problems from the textbook. Now, to get us started though, we're going to build up by working just with numbers before we get into the variable terms. So our goal here is to factor with the distributive property, and we are going to factor out the greatest common factor from each expression. So let's start with 15 plus 35. So we are looking for what is the greatest common factor of 15 and 35 that we can factor from it. Well, let's do a little review from the previous video in which we changed each of these numbers into prime factors, and then we compared the prime factor lists from each number. So if I have 15 and 35 and I go to factor this according to prime factorization, we would have 3 times 5, and we would have 5 times 7, right? 3 times 5 is 15, 5 times 7 is 35. If I was to then group these numbers, so we'd have 3 times 5 here, and we'd have 5 times 7 here. We group by columns, in other words. Let me actually line this up. So 5 times 7. We can see that our 5s are the 2 common factors. In other words, they are grouped into one column. 3 and 7 are currently not covered, so they would not be part of the problem. So what we've just done here is we've identified that the greatest common factor for 15 and 35 is the number 5. So now what you're basically going to do is you're going to take the distributive property and you're going to put the greatest common factor on the outside of the parentheses. And then you can divide 15 divided by 5, which is 3, plus 35 divided by 5, which is 7. And now you have factored out the greatest common factor. So we have 5 parentheses 3 plus 7. You again could multiply 5 times 3 to get to 15 and 5 times 7 to get to 35 to get back to where you were just at. Okay? So this is our answer for this particular problem. Let's take a look at the next one. So question 2, we have 24 plus 36. Again, we want to factor out the greatest common factor. So let's do the prime factorization of 24 and 36 to start, to see, and then match up the columns to find the greatest common factor. So for 24, we have 2 and 12. If I start with the smallest prime number, and we have 2 and 6, and we have 2 and 3. Okay. So now that we have the prime factorization of 24. For 36, we then have 2 and 18. 18 can be factored down to 2 and 9. And then 9 can be factored down to 3 and 3. Okay, so at this point now, let's go ahead and line up our columns. So we have 2, 2, 2, and 3 for 24. So 2 times 2 times 2 times 3. And 36, we have 2 times 2 times 3 times 3. So if I look at the columns that are grouped together, we have 1, 2 that's grouped. We have a second 2 that is grouped. And we have a 3 that is grouped. In other words, this 2 and this 3 are not grouped, so they do not fall down into the greatest common factor. Our greatest common factor then is going to be 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is equal to 12. Now, you might have figured out what the greatest common factor is without doing all of this prime factorization here. And if you can, totally fine to do. I like to show this and use this as a method because this gets us in the habit of doing prime factorization, gives us more chances to see that method in play, which can be very useful for other types of problem solving. So from here then, 12 is the greatest common factor. That goes on the outside of our distributive property parentheses. And then we can do 24 divided by 12 to get the first number in the parentheses, 2, plus 36 divided by 12 is going to be 3. So now we have this factor, 12 parentheses 2 plus 3, and that is the reverse distributive property of this particular number. Let's look at question 3 here. So question 3 is going to be 18 plus 30. Now let's assume we kind of understand the prime factorization now, how to find the greatest common factor. So the greatest common factor for 18 and 30 then is a GCF that is equal to 6. So the greatest common factor of 18 and 30 is a number 6. So I'm going to put 6 on the outside of our parentheses. And then we can do 18 divided by 6 to get 3. That's the first number within the parentheses. And 30 divided by 6 to get to 5. That's the second number in the parentheses. So we have now factored out the greatest common factor, and our parentheses now reads as 6 parentheses 3 plus 5 here. And we are finished with factoring out whole number greatest common factors. Next, I want to look at what are terms in a polynomial. So a polynomial is a mathematical expression made of terms that use numbers, variables, and whole number exponents combined by addition, subtraction, and multiplication. If I take a look at this first example here, 12x squared minus 18x plus 6, there are 3 terms in this particular polynomial. The first term being the 12x squared, where 12 is the coefficient and x squared is the variable part. We then have 18x, which is the second term, 18 being the coefficient, x being the variable part. And then we have a third term, which is just a counting number or constant, number 6 here. Now let's take a look at our core concept, factor the greatest common factor from a polynomial. So our first question then is looking at 12x plus 18. And our first step is to find the greatest common factor of all the terms of the polynomial. So we have 2 terms in this one, 12x and 18. So the first thing that we're going to do to find the greatest common factor, that I like to start with at least at the beginning, is to break this down into its prime number factor form. So 12x can be factored down into 2 times 2 times 3, that's the 12, and then it has the x term left over, so expanding it out to with the x term as well. So 2 times 2 is 4, 4 times 3 is 12, 12 times x is 12x, and then 18, we have 2 times 3 times 3, and no x term as well. So now let's go ahead and combine the common numbers. So we see that we have a 2 and a 2 here to start. And we also have a 3 and a 3 to start. This 2 and this 3 are not covered, and the x isn't as well. So our greatest common factor for this one then is going to be equal to 2 times 3, which is equal to 6. So step 1, find the greatest common factor of all the terms of the polynomial. Well, that is 6. Now we need to rewrite each term using the greatest common factor. So 12x, using our greatest common factor, would be equal to 6 times 2x. So 6 times 2 is 12, and then I have the x term as well. So 12x is my result there. 18 then can be rewritten as 6 times 3 is 18. So step 2, rewrite each term as a product using the greatest common factor. Then using our reverse distributive property, essentially what this is 6 times 2x plus, put the x there, plus 6 times 3. And then using the reverse distributive property, the 6 goes on the outside of the parentheses, and the 2x plus 3 go on the inside. And now this matches up to the distributive property form. That is our answer. Step 4, though, we can check our work by multiplying the factors to see if we did this correctly. So if you do this, you can multiply the 6 times the 2x. So 6 times 2x is 12x. And then you can multiply 6 times 3, which is 18. And we can confirm that 12x plus 18 is our result here. Let's look at question 2 now. So we have 18x to the third power minus 24x squared, and we're asked to factor the greatest common factor from a polynomial, this being our polynomial. We again have 2 terms here that we're taking a look at. So step number 1 is to find the greatest common factor of all terms of the polynomial. So first off, starting with 18x to the third power, this can be written as 2 times 3 times 3 times x times x times x. 24x squared then can be written as equal to 2 times 2 times 2 times 3 times x times x. Then matching up the common factors, I see a 2 and a 2 that matches up. So that's the first term that can match up. I then see a 3 and a 3 that match up. But I don't see these 2 2's match up with anything in the 18x to the third power, nor do I see another 3 that matches up here. So that's all we can do for the number terms, or the number parts. And then for the x variable, I see that we have 2 x's that match up to the 2 x's above. So this third x doesn't match here. Now, this again goes back to the shortcut we talked about in the previous video, where you can essentially choose the term that has the lowest power, x squared in this case. So our greatest common factor then is equal to 2 times 3 times x times x. So our GCF can be written as 2 times 3 is 6, x times x is x squared. So our greatest common factor is 6x squared here. Next, we're going to rewrite each term as a product using the greatest common factor. So 18x to the third power can be rewritten as 6x squared times 3x. In other words, 6 times 3 is 18, x squared times x, basically adding the x squared part with the x to the first power. You could put a power there. So 2 plus 1 being 3. Okay, so 6x squared times 3x. And then we have 24x squared, which is 6x squared. And there is a minus here. I should put a minus there. So 6x 6x squared, I should say, times -4 as my result. Okay, so that is step number 2. Rewrite each term as a product using the greatest common factor. Then if I was to put this in more factor form, we would have 6x squared times 3x minus, So this is the minus part here. That minus 4 goes here. 6x squared times 4. And from there, we can put into a distributive property form where this 6x squared, the greatest common factor, goes on the outside of the parentheses. And on the inside of the parentheses goes the two terms here. So 3x minus, that's the core difference. We have a minus symbol. And then the 4 here. So our answer for this, step 3, use the reverse distributive property to factor. We would get 6x squared parentheses 3x minus 4. Now, if I check my work by multiplying the factors, we can do that by multiplying into each of these terms. So 6x squared times 3x is my 18x to the third power. 6 times 3 is 18. X squared times x is x to the third power. 6x squared minus 4. 6 times 4 is 24. And then I have the x squared that's left over. So we have confirmed our work with step number 4. For the third question, we have a polynomial that has 3 terms. So we're asked to factor the greatest common factor from a polynomial, 15x to the third power plus 20x squared, so x to the second power, minus 10x here. So our first step, once again, is to find the greatest common factor of each of the 3 different terms. So to do that, I'm going to expand this out. So 15 is 3 times 5, that's the coefficient part, times x times x times x. 20x squared then is 2 times 2 is 4 times 5 is 20 times x times x. And then 10x is going to be 2 times 5 times x. Now, when we find the greatest common factor, we have to find a number or a variable that appears in all 3 numbers. So, for example, the number 3 does not appear in the other number lists. The number 2 appears in 10 and 20, but not in 15. The only number that appears in all 3 then is the number 5. So 5 is one of the terms. And then I go to the smallest variable part. So this is x to the first power. So there's only one x that appears in each of the lists here. So in other words, our greatest common factor is equal to 5 times x, which can just be consolidated down to 5x here. Okay, so step 1, our greatest common factor is 5x. Next, let's rewrite each term as a product using the greatest common factor. So if I start with term number 1, 15x to the third power, this can be written as 5x times 3x squared, right? 5 times 3 is 15. X times x squared is x to the third power. 20x squared then can be written as, again, starting with the greatest common factor, 5x. And then 5 times 4 is 20. And x times x is x squared. So it can be written as 5 times 4x. And then finally, negative 10x can be written as 5x times negative 2. 5 times negative 2 is negative 10, the x left over. From here then, I can write each of these 3 different terms. So this is a little interesting as a distributive property because there are 3 terms here. So we have 5x parentheses 3x squared, 5x times 4x, and then we have a minus 5x times 2. Now, if I was to then put into more distributive property form, we put the 5x, the greatest common factor, on the outside of the parentheses, and then each of the three terms on the inside. So we have 3x squared plus 4 x, got the x here, sorry guys, x up there, minus accounting number 2. So this is the distributive property when we have three terms here. And this is our answer. Now, if you want to check your work again, you can multiply in each term. So 5 times 3x squared. 5 times 3 is 15. X times x squared is x to the third power. 5x times 4x is 20x squared. And then 5x times negative 2 is negative 10x. So again, that gets us back to where we started there. So that's question number 3. Question number 4 then is to factor the greatest common factor from a polynomial, this polynomial being negative 6x to the third power plus 42x squared minus 18x. So finding the greatest common factor, we have negative 6x to the third power. So what we have here is 2 times 3. And the other thing to note is usually when the first term is a negative, it is often cleaner to factor out a negative GCF. So that's where I actually like to put a negative 2 here. So our greatest common factor at the end will be negative. And then we have times x times x times x. And then we have 42x squared here. So 42 is going to be 2 times 3, which is 6, times 7, which is 42, times x, and then 18x is going to be 2 times 3 times 3. That looks like a 3. 2 times 3 is 6, 6 times 3 is 18, and then we have an x left over here as well. So then matching up our terms, I see a 2 that appears in all the lists. So 2, 2, and 2. And then I see a 3 that appears in all the lists. So 3, 3, and 3. The 7 does not appear in all 3 lists, and the extra 3 does not as well, so those get eliminated. And then I have one of the x terms. So the smallest variable part is just x to the first power. So rewriting this, our greatest common factor, again, remember the negative here, is going to be 2 times 3 times x. So our greatest common factor is equal to negative 6x here. Okay, so that is our greatest common factor. Step 2, rewrite each term as a product using the GCF. So we have negative 6x to the third power. So our greatest common factor then is negative 6x, that's the first part. And then this is going to be multiplied by x squared. So negative 6 times, basically a 1 is negative 6, x times x squared is the x third part. Then we have 42x squared. So we start with negative 6x. Now this is interesting here because this is a positive 42 and I have negative as my greatest common factor. That means I need to put a negative term on the inside here. So 6 times 7 is 42, so I have a negative 6 times a negative 7, and then I have an x times an x to get the x squared part. So negative 6 times negative 7x, and then I have negative 18x, which can be written as negative 6x. Since it's a negative term, we're going to put a positive 3 here, so plus 3. Okay. Now, if I rewrite each of these terms, negative 6x, x squared, minus 6x, and negative 7x, minus 6x, positive 3. So these are our 3 different terms now. We are going to now put in distributive property form by taking the negative 6x on the outside of my parentheses, and then on the inside, we're going to put each of these 3 different terms here. X squared minus 7x plus 3. So my answer now would read negative 6x parentheses x squared minus 7x plus 3. Now checking our work, step 4, check by multiplying the factors. If I was to then multiply through, negative 6x times x squared is negative 6x to the 3rd power. Negative 6 times negative 7 is positive 42. X times x is x squared, so we get plus 42x squared. And then negative 6 times 3 is negative 18. I have that extra x term, so I would get minus 18x. Okay, so we've confirmed our work at the end. Okay, so that is question number 4. So question number 5 is to factor the greatest common factor from the following polynomial: 24a to the 5th power and b to the 2nd power plus 36a to the 3rd power, b to the 4th power. Okay. There are 2 terms for this particular polynomial. However, it looks kind of complicated because it has 2 of the variable parts with exponents tied to it. So let's first start with 24a to the 5th power, b to the 2nd. That's the first one. Might run out of room here, so let's just go ahead and write the expanded factorization from it, prime number factorization. So 24 is going to be then 2 times 2 is 4 times 2 is 8 times 3 is 24. And then I have 5 a terms. So a times a times a times a times a, and 2 b terms, b times b. Now, in reality, again, if you're comfortable with knowing that, I have these 5a terms and the 2b terms, you don't really necessarily need to expand it, really, because there are variable parts that have a variable parts that appear in both of the terms. You can just take the smallest one. So we would just take a to the 3rd power, and we would just take b to the 2nd power there. Right? So instead of listing all this out, you could just do that. But just to confirm our thought process, let's make sure that we are able to do it. So then 36 is going to be 2 times another 2 times 3 times 3. So 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. And then we have 3a terms, so a times a times a. And we have 4b terms, b times b times b times b. Okay, so this is really expanding it out. If I was to then find the common terms here, we have a 2 and a 2. We have another 2 and another 2. And then we have a 3 and a 3, while this 2 and this 3 are not covered. So that would finish for those terms. And then for the variables, I see 3 of the a terms. 2 of the a's are uncovered here. And then we would also have 2 of the b terms that are covered. Okay? So if I was to then list out my greatest common factor, we would have 2 times 2 times 3 times a times a times a times b times b. Now multiplying these out, 2 times 2 is 4, 4 times 3 is 12. 3 a's is a to the third power, and b to the second power. So this is our greatest common factor then for this problem. Next, we can rewrite each term using our greatest common factor of 12a to the third power, b to the second power. So starting with our first term, we have 24 a to the fifth power, b to the second. So starting with our greatest common factor, 12a to the third power, b to the second, what you're basically doing here is you're asking, okay, what number do I multiply by 12 to get to 24? Well, that's just a number 2, right? So we would have 2. Then I'm asking myself, okay, since I have 3 a terms, how many a terms do I basically need to add, although you're multiplying it to get to 5? And that's 2 of them, right? So 2a squared would get us to a to the fifth power. And since I already have in my greatest common factor 2b terms, and that's the 2b terms here, that's all I would do. So 12a to the third power, b to the second power, times 2a to the second power is the rewriting the first term as a product using the GCF. The next term then, 36a to the third power, b to the fourth power, could be rewritten, again, starting with our greatest common factor. And then in this case, what number do I multiply by 12 to get to 36? Or you could say 36 divided by 12. Well, that is just a number 3. We already have matching a terms. We just need, let me do a bigger 3 there. We just need 2 more b terms to match up. So we would say 3b squared. So that's step number 2. So then if I was to rewrite this as the factors, we have 12a to the third power, b to the second, times 2a squared, plus hopefully don't run out of room. Really close. Okay, so now we have our 2 terms written. Let's write using the reverse distributive property to factor. So again, we start with our greatest common factor. That's this guy. So we have this on the outside of our parentheses. And then on the inside of the parentheses, we have our first term, 2a to the second power, plus 3b squared here. Okay, and that is our answer for question number 5 here. Now again, if I checked by multiplying the factors, you could 12a to the third power, b to the second power, multiply it in. 12 times 2 is 24. And then the 3 and the 2 basically adding together gives me a to the fifth power, b to the second, plus 12 times 3 is 36, a to the third power, and then b to the second plus b to the second really becomes b to the fourth. Well, it's multiplying, but the 2 and the 2 together gives me 4. Okay, so that, we're not boxing, that's not our answer, but we can check our work here and note that we've come to the correct conclusion. The final question in this series is slightly different in that it asks to factor the greatest common factor from a binomial polynomial. So we've been looking at monomials, but basically binomials in this case is really a little easier because if I look at this, do you notice how we have x plus 2 as the item in our, let's not put the 3 in the parentheses yet. We have 3x plus 2. Whenever you see this, if I have similar terms like this, x plus 2, what you're going to do is that can become the first, basically the greatest common factor in this problem. So that goes on the outside, the first parentheses. And then the two numbers that are on the outside of the parentheses that are next to the common factor then goes in the parentheses as well. So 5x plus 3. So when we're factoring a binomial polynomial like this, the x plus 2, the common factor becomes your greatest common factor. That goes on the outside. And then the two terms that are right next to it goes on the inside. And you're actually done with that. So fairly straightforward in comparison to some of the other problems. One thing I want to make sure to highlight as a common mistake to avoid is to do not include a variable in the GCF unless it appears in every term. So for example, if I have 8x to the second power y plus 12x y to the second power plus 20x, do you notice how the y term only appears in the y variable part only appears in the first two terms, here and here? It does not appear in this third term. So you would not put a y variable in the GCF. That is often a mistake that is made, is that we see, okay, we have two y terms, so that must be in the greatest common factor. It's not. So the greatest common factor for this one would just be the number for 8, 12, and 20 is 4. And then we have x terms that appear in each of these. The smallest of the x terms is just the x to the first power, so it would be 4x. Okay, so wanted to highlight that before we finished up this presentation. The last thing to note for this is I have a series of questions within the guided notes. So there are 8 total questions that you'll find in the guided notes at the end. These are these questions, so it kind of covers a few of the things that we just looked at. I'd go ahead and run through those practice questions, and then you can find the answer key on the next page in the guided notes. So feel free to take a look at this. If you have any questions after going through these questions, feel free to send me a message or put it in the comment section, and we'll follow up with it. So good luck, everyone, and thanks for sticking with me.